In this video, we are going to talk about the two-dimensional thin layer chromatography, the 2D TLC. What you're seeing right now is the setup of the experiment. On our right, we have our samples. So we have our standards 1, 2, and 3, and also our sample that we want to separate. To the left, we have our TLC plate. On the plate, there's a thin layer of silica gel on it. The silica gels are mildly polar and will bind to polar components and compounds. And this will help us to separate the lipid mixture according to their polarity. To our left, this is a template that we use to put on the silica gel for us to load the sample. It's important that we cover it because silica gels are on the plate are very fragile, so you don't want to touch it, and this will protect you from touching the plate when you're loading your sample. And you also have our pipettes. On the top, we have our developing solvent. So we have two different developing solvent. For our first dimension is the basic solvent, and the second dimension is the acidic solvent. Using two different solvent will change the polarity of the lipids in each environment, and this will help us to give us a better separation. Here we have two developing tank. This is where we pour our solvent in, which is already in the tank, and also where we put our plate to develop. Also, to the far right hand side, we have our iodine tank. The iodine will bind to our lipids, and it's at the end when we want to see our samples, we'll put it in and it will put color into the spots, and we're able to visualize our lipid sample. And last but not least, we have our blow dryer or hot gun. This is very important because we want to evaporate the solvent before we change into a different dimension, and also before we put our TLC plate in the iodine tank. The whole setup is in the fume hood. It's because our solvent had chloroform in it, and also acetone and methanol, and those are all organic compounds that can be airborne. And so we want to keep everything in the fume hood, and also our iodine as well, because in the tank we fill with iodine vapor, and we don't want that to get out of the fume hood. This is the setup that you will see when you come in the lab on the bench for you to load your sample on the TLC. Because we're loading the sample outside of the fume hood, it's very important that we keep our sample on ice. This is to prevent it from evaporating. Because you keep it in the cooler temperature, so it'll be lower than the boiling point. So here we have our TLC plate with our template plate already laid on top. We have some holes to put your sample, and also your standards, and also for your labeling, and we will also draw a line there later on to indicate where the sample is, and also your sample on ice. Now we have a closer look on our TLC plate and the template. I'm going to show you what we're going to do. So before you load any sample, first of all, you want to draw the line here, just following the template, and draw another line across. This is to indicate where your sample is going to go and where the solvent fund is going towards. Also, you want to label your plate. You can put the date and your group number and so on, but for demonstration purpose, I'll just put demo. Also, after that, you want to indicate the direction of your developing solvent and where it's going. So I'll say this one is the first dimension, which is going upwards, and the other side is the second dimension, which is going from there to there. Now we're ready to load our sample. So first we will load our standards, which will be in this window and that window. So we're loading 3 different standards. Each standard we're loading 5 microliters. So now we're loading standard number 1. When you're loading the sample, try not to touch the plate because it's very fragile. So sample number 1 over at the far corner as well. And sample number 2, same thing. Number 2 over on that side. Number 3. And number 3 over on that side. So the 3 samples are 3 different lipid mixture, and it will help us to identify what's in our mixture sample that we're going to separate. So after you load the standards, we are loading the sample. For the sample, we're loading 10 microliters, and we load it in the same way we do the standards. So just go over that holder and just slowly add it on the plate. Okay. Good. So after we load the sample, it's important that we double check if the things are in there. So if you see now, the ones with the sample had a white shadow on your TLC. So if you have any sample loaded in, you will see that shadow on your plate. So after you loaded all your sample and your standards, you can transfer your plate into the fume hood on the plate holder. So this is the plate holder, and it can put up to 6 plates all at once, so we can develop them all at once. So after it's on the plate holder, we're going to transfer this into the developing tank for our sample to develop. So in this first dimension, we have the basic solvent. The solvent is going to travel on your TLC plate through the capillary reaction. So it's going to travel upwards. And when it reaches to almost to the line that we draw earlier on, then we can take it out and stop the development. So now our solvent has traveled all the way to the top of the plate right there, and we're ready to take this out. But remember, after you take it out, it's very important that you draw where the solvent front is, and this is to help. You need that to calculate the RF value of each of your lipid. And your developing solvent is going to evaporate very quickly, so you want to draw it like pretty much right away, immediately. We'll just draw a line. It doesn't have to be perfect, but indicate where the solvent front is. So after we draw the line that indicates the solvent, we have to dry, completely dry all the solvent on the plate. It's because our first dimension is the basic solvent with ammonia in it. And the second dimension is acidic solvent with acetic acid. And if we put this right away, it's going to build up salt because it's acid and base reaction. And that would affect the separation of our lipid sample. And also ammonia, it's volatile. So when you dry it, it's actually removing it completely off the plate. So now we can start drying. So when your TLC plate is completely dry, the plate is going to be more opaque, so less translucent. And also you want to feel the back of the plate. If it's a little bit warm, then that means everything is evaporated. So now we're ready to do the second dimension for our developing in our acidic solvent. You have to turn the plate to the next dimension. You have to remember to do that. So now we're switching the plate into the second dimension so that your first dimension line is actually perpendicular to your solvent. And you're ready to put it in the developing tank. So again, we'll wait until the solvent line climbs up to here, and then we can take the plate out and then to stop the development. So now again, you can see that the developing solvent is climbing up to this line, and you can see that where the solvent is, it's more translucent. We are ready to take this out of the tank. Again, you want to draw the solvent front before it evaporates. So you draw them right over here. Okay. And then you're ready to dry the plate, and then we can put it in the iodine tank for visualization. So now our TLC plate is completely dry. We are ready to visualize them with iodine. And in the tank here, we have the crystal at the bottom of the tank, if you can see it. And the crystal will produce iodine vapor, and that fills up the whole tank. So you'll see this purplish, brownish vapor that's in the tank. And that vapor is going to attach to your lipid sample and produce a yellowish dot on it. And yeah, and that's how you visualize your lipid sample. So we can put our plate inside to develop. So now you start to see the yellow dots that are appearing on your TLC plate. Those are where the lipids are. We are ready to take this out from the iodine tank. And we can take a closer look at it. So you can take a closer look of the plate. You want to start circling your lipid dots because the iodine is volatile and it might disappear. Okay. So just start circling all your dots that's on your plate. So after we circle all the dots, we can compare our lipid sample to our standard. So we can compare each dot, and we can identify what lipids is in our lipid sample.